When astronomers began tracking 3I Atlas, most people focused on how fast it was moving and where it was going. But what really makes this object extraordinary isn't just its path, it's its age. Early modeling suggests that 3I Atlas could be older than our solar system itself. Not just older than Earth, older than the Sun, a fragment of material that formed in another star system long before our own even existed. And that possibility changes how you look at it, because that would make 3I Atlas not just a visitor from elsewhere, but a relic from a deeper past. Our solar system is about 4.6 billion years old. It formed from a swirling disk of gas and dust, left over from earlier generations of stars that lived and died before the sun ignited. Everything here, from planets to comets to asteroids, comes from that same local material cloud. But 3I Atlas doesn't. If it truly originated outside our system, it likely formed around another star that existed long before our sun was born. That star could be billions of years older. Its planetary system could have formed, evolved, and even been destroyed long before Earth ever coalesced. Which means 3I Atlas could be carrying material shaped in a completely different cosmic era, possibly older than anything else we've ever directly observed passing through our neighborhood. This idea didn't come from science fiction. It came from analyzing its trajectory and velocity. Interstellar objects don't just wander randomly. Their speed and direction contain information about where they've been. When scientists examine how fast 3I Atlas is moving relative to our sun and compare that to the motion of nearby stellar neighborhoods, they can estimate whether it came from a young system like ours or a much older environment. And based on current data, 3I Atlas doesn't seem like debris from a region of recently formed stars. It appears to be moving like something that has been drifting through the galaxy for an extremely long time. A cosmic drifter, maybe for billions of years. In that sense, 3I Atlas could be older than Earth, older than the dinosaurs, older than life as we know it, older than the sun's first light. And that's where its full story becomes mind-bending. Because if it is that old, then every atom of it has survived unimaginable conditions. It would have endured waves of cosmic radiation that have shaped galaxies, passed through regions of interstellar medium filled with high-energy particles, possibly even moved through the outskirts of supernova shock waves, stellar winds, and dense molecular clouds. And yet, here it is, still intact enough to be detected, still structured enough to hold together, still carrying chemical signatures of a world that existed before ours. What's even more remarkable is that unlike meteorites found on Earth, which are remnants of our own solar system's formation, 3I Atlas potentially represents the leftover architecture of another star's world. It's not just rock, it's history. Not geological history like on Earth, but cosmic history. A physical token of processes that happened long before humans, long before mammals, long before the planet itself. Astronomers believe that many star systems go through violent phases as they evolve. Planets migrate, massive bodies collide, moons shatter. Entire worlds can be destabilized by gravitational shifts or passing stars. During those chaotic periods, debris gets flung outward at extreme speeds. Some of it escapes the system entirely. And when that happens, those fragments begin a new life as interstellar travelers. 3I Atlas likely began like that. It might have been part of a larger body, a comet-like object, a fragment of a shattered protoplanet, or even debris from the outer edges of an ancient planetary system disturbed millions or billions of years ago. When that system destabilized, this piece was ejected, and it never came back. It just kept moving, through star systems, through spiral arms, through the quiet, nearly empty stretches of interstellar space, until it drifted near our solar neighborhood and gravity pulled it into a brief conversation with the sun. What we're seeing isn't just an object. It's the end of a very long journey, and possibly the only moment it will ever be this close to any star again. What adds to this sense of age is its chemical and physical state. 3I Atlas doesn't behave exactly like comets born around our sun. Its surface chemistry appears more complex. Its reaction to solar heating is uneven. Its structural response to temperature changes doesn't match youthful solar system debris. It looks weathered, not like something that spent billions of years near a star, but something that's been processed by the harshness of deep space. Cosmic radiation alters materials at the molecular level over time. It breaks bonds, rearranges atoms, darkens surfaces, hardens outer layers. If 3I Atlas has truly spent billions of years exposed to that environment, it would show signs. And scientists believe it does. Its surface albedo, its spectral reflectivity, even its subtle color variations suggest prolonged exposure to interstellar conditions rather than just local solar space. This doesn't mean every part of 3I Atlas is ancient in the same way. Parts of it could have fractured more recently. Its journey might have included collisions with micrometeoroids or slow erosion from dust. But its core structure may be a direct survivor from an era that predates our entire solar system. Which means when we study it, we're not just studying an object. We're studying a time period we can't otherwise reach. We can't travel back to before the sun formed. But we can analyze material that existed before it. That's a powerful thing. It's like finding a fossil older than the continent it's sitting on. A physical piece of a different time. And that's why 3I Atlas matters far beyond the sensational headlines. Not because it might be alien life, not because it could be artificial, but because it's a messenger from a time before our cosmic home existed. A natural time capsule, and perhaps the oldest visitor we'll witness in our lifetime. What makes this even more poetic is that Earth itself is built from ancient fragments too. The elements inside your body were forged in stars that lived and died long before the sun existed. Supernovae seeded the material that formed our planet. In a way, we are also made of ancient stardust. But 3I Atlas is a more intact version of that story. It wasn't melted and reshaped into a planet. It wasn't absorbed into a star or compressed into a world. It stayed separate, preserved in the cold, dark silence of the galaxy. And now, for a tiny window of time, it's close enough for us to observe. We don't know if we'll ever get this kind of opportunity again. Interstellar objects like this might pass by often, but detecting them with modern instruments is still new territory. Our surveys are improving, but we're only just beginning to notice these visitors. 3I Atlas might be one of the first of many, or it might remain one of the rarest we ever study. Either way, it's already changed how we think about age in the universe. Not just star age, not just galaxy age, but object age. Because until recently, most of what we studied came from our own system, our cosmic backyard. Now we're catching material that formed under other suns, in other environments, in other timelines. We're expanding our understanding of history beyond our solar neighborhood. And when you think about it that way, 3I Atlas isn't just an interstellar comet. It's a surviving witness, a fragment of a long-dead system, a traveler older than our sun's light, passing silently through our sky, reminding us that our world is young, our system is young, and the universe has been telling stories long before we ever learned how to listen.